1-2A is what we're doing today. And this is pretty much the heart of geometry, I would say. Like, this is the core, the key terms that you're going to use throughout this course. So get familiar with these, know how to use them, know how to write them. It's not a lot of like applying the knowledge today. It's more just understanding what the different terms are and how you name them. Okay. So we're going to start with a point. And the point, line, and plane are not definable terms. So they're giving a description of it, but technically they're considered undefined terms. So a point is a location, but it has no size, so it's really hard to define it because it's just like a spot, right? So the way you write it, what I would recommend is if you're going to write into your notes, maybe in Notability or something, however you want to do this, I would just write right on this PDF. If you want to write on a separate piece of lined paper, you go right ahead. But a point, we would do something like this. So you have a little point, and then you put a letter right behind it, and it just depends what that letter is representing. So for instance, if I did this, we would call that point A. Okay. A line is a straight path that extends in two opposite directions and has no end. So a line keeps going forever, and it's really hard to draw something that goes on forever, right? So that's why we put the arrows on the end of it. We do it like this. An arrow here, an arrow there. And it has infinitely many points on it. So every single part of red that you see right now, other than the arrows themselves, is a point. So it's just a slew of points all lined up that makes a line, okay? With that, you're going to pick a couple points to name it. So you need 2 points to name it. You name it with 2 points. Okay, so if I were to put a point here and call it X, and a point here and call it Y, I could say this line is line XY. So you would do XY. And the way we represent a line is we put a line over top of the letters. So we're going to do a line over top like this, and that is line XY. Okay. The beautiful thing about a line, though, is you can name it a lot of different ways. So right now, I could also name it line YX, and it's the same line. Okay, so if I flip-flop my letters, still the same line. We would just call it line YX instead of line XY, but it is the exact same set of points. Okay. A plane is a flat surface that has no thickness. Again, hard to define because it's going to go on forever. So, for instance, if I were to take a piece of paper to represent it, this paper has thickness, right? There is some amount of thickness to it. It's very little, but it has thickness. A plane does not have thickness. So if this were my plane, it's going to go on forever in every direction. That's what a plane does, okay? The way you name a plane, well, first of all, the way we typically draw a plane looks like a parallelogram because there's just not a good way to draw a plane because it doesn't technically exist in any thickness, right? So if I were to do this, okay, that would be considered a plane for now. The way we name it, you have to use at least 3 points. So name it with at least 3 points. Okay, unless you have a letter there that is not a point. So sometimes they'll give you just a letter up in the corner and no point in front of it. Okay, if they give you this, you call it plain P. Okay, so you can name this right now plain P, but that is the only time you can use one letter, is if there's not a point in front of it. If there are points in front of it, then you need at least 3. Okay, so if I gave you A and B and C, the way I would name this right now is I would call it plain ABC. And usually we just put things in alphabetical order. It's not wrong to call it plane CAB. That's fine too. But typically we just stick with alphabetical. Excuse me. Now here's the thing about a plane. You can do 3 letters, but you could also do 4. You could do 5. You could do 6. So you need at least 3, but that's not the limit. You can do as many letters as you want. Okay? So that's a plane. Any questions, point, line, or plane so far? All right. Then we're going to move up here to collinear. And when you look at collinear and coplanar, what do you see in those words? Co, right? So if you think of like a co-worker, that's someone you work with. A co-conspirator, that's someone you conspire with, right? So collinear, coplanar, they're with each other on the line, or they're with each other on the plane. So it's points that lie on the same line. Coplanar is points that lie on the same plane. Okay, so if I had a point here and a point here, and this was A and this was B, and I could draw a line through them, which any 2 points you'll always be able to draw a line through. Oh, that was bad. Let's try again. Still not great, but you get the idea, right? If I can draw a line through it, they are collinear. They lie on the same line. Okay. Coplanar means they lie on the same plane. And this one can be a little bit tricky for people at times, because if I were to draw this plane, for instance, okay, and I have point G, point H, point I, okay, those are coplanar. They all lie on the plane that I'm looking at. But if I were to draw a point up here, okay, and call it point F, technically I could say that F, G, and H are coplanar as well, which is tricky because it doesn't look like they're coplanar because they're not lying on the plane that I drew, but there is a plane that we could draw through them. So any 3 points are always coplanar. We'll talk more about that tomorrow. But these 4 right now, we would say are non-coplanar, right? So these 3 are coplanar. These 4, F, G, H, I, are non-coplanar because there's this plane for G, H, I, and then there's this point up here, and there's no way I can go through all of those with one plane, okay? So that one takes a little while to wrap your brain around usually. Don't stress too much about it. We go over it more as we go through things, but just keep that in mind. Any questions so far? I know this is a lot of information. Tomorrow is less information, more doing, so that's helpful. Okay, then what we're going to do is I'm going to give you an example here. So here's a plane. And we have P, and then R, Q, and V. I switched it up. This is S. Pretend that's a straight line. This is T. This is N. Any guesses what the dotted line means? Yeah. It's behind the plane. It's hidden, right? So if this is my plane right here, basically what's happening is line QT or line TN, however you want to think of it, that line that's going more vertical is cutting through the plane, right? It's not lying on the plane. So if the whole thing is solid, it is lying on the plane. If it's got the dotted line, it's kind of hidden, so it's going through until it passes through and you can see it again, okay? So if this is our setup, can you tell me Another way that we could name the line QT. So if I have line QT, can you tell me another way to name that? You can name it TQ, okay? Is there another way? TN, right? So any 2 points on that line, it's the same line because lines go on forever. So QT goes on forever, TN goes on forever. They are the same. So TN would be another way you could name that. QN, NQ, right? So several different ways you could name it. How about, could you name plane P for me? Plane RSV. Okay, so another way to name plane P. Why am I naming it plane P? Why is that allowed with just one letter? Because there's no point in front of P, right? But the ones that have the points, you have to use at least how many? At least 3, okay? So this could be plane RSV. Now, let me tell you another little tricky detail about naming a plane. Where do you see 3 collinear points on that plane? Okay, on the other plane, if going vertical, there is a plane that goes through those. Okay, so here's the thing. When you have 3 points on a straight line, okay, so like my arm, for instance, right? A point here on my fingertip, a point at my wrist, and a point at my elbow. How many planes go through those 3 points? It's more than that. It's an infinite number, okay? Because I could go through here, or I could go through at this angle, or I could go through at this. It just keeps going. There's an infinite number of planes that cut through those 3 points. So if you have 3 points on a line, you can't use those 3 to name the plane because we don't know what plane you're talking about, right? So I'm not going to name this plane RQV. I'm going to name it RQS or RSV, okay? So 3 non-collinear points, 3 points that don't lie in a straight line is how you want to name a plane, okay? So we could call this plane, let's see, R what? RTV would be a different plane. That would be a vertical plane because T is not on that plane. But if we do RSV, so RQS you could do. Okay, what you cannot do is you can't call it plane RQV, okay? So this one doesn't work because that's a bunch of different planes that go through that, okay? How are we doing so far? Okay, can you tell me 4 coplanar points? 4 points that all lie on the same plane. I missed the last one, RSVQ, right? Those all lie on the red plane that's drawn in, okay? You could do NQTV because you have that vertical plane and it would cut through kind of back on an angle. So if you have 3 on a line and 1 other point, there's a plane that cuts through there, right? So that's a possibility there too. So far, so good? Doing okay? A lot of information, I know. Okay. Then, moving on. Last 4 terms, and then one last example for you. Space is the set of all points in the 3-dimensional world. So everything's in space, right? Space is all around you, okay? A segment is, instead of a line, right? A line we said goes on forever. A segment has endpoints. So it's going to look fairly similar, but be different at the same time because what you have is an endpoint here and an endpoint here. So if this is B and this is T, okay? no arrows on the end means those are your stopping points, you're done. Okay, that's a segment. So we name it like this, BT, and then we just put a segment over top, no arrows, okay? And we would call that segment BT. Okay. If you name it segment TB, is it a different segment? No, it's the exact same segment, okay? So when you name a segment, you can do it in either order. You don't need to do both of them because they are the same thing. So BT or TB, don't do both, okay? Okay, array. Now array is kind of the combination of a segment and a line because one end goes on forever and one end has an end point. So with this one, it can be a little bit tricky on how you name them. I will show you a few different examples. Let's see. Okay, so here's 3 rays. They have an endpoint on one end and a line that keeps going on the other. Now, when you name a ray, you always start at the end point. So if I go here to this first one that I drew, can you tell me what letter should be which letter should come first? Your L, okay? The end point is your start point. So this would be ray LM, and then you put an arrow to the right, okay? What comes first on the next one? The T. Always your end point. So it's going to be TR, but now here's where people get a little confused. Your arrow points to the right here, right? But because we started at T and went through R, that's how we want our arrow to be represented. So when you name it, your arrow will always point right, okay? Because you always are starting at your end point. So TR, this would be ray LM. This would be ray TR. Okay, so how would you name that last one? KP. Yep, it's ray KP. So you do KP, arrow goes to the right. Okay. Any questions on rays? Okay, then the last thing is opposite rays. And opposite rays are just 2 rays that share an endpoint, but nothing else about them overlaps. So if I have a segment here, or a line here, okay, basically what happens is if I take 3 points, so this is T, R, and S, okay? Opposite rays have to share an endpoint, and you have to name a ray with 2 letters. So our endpoint, if we're talking opposite rays here, our endpoint is going to be the R. Okay, that means I have a ray going to the left, like this, and I have a ray from R going to the right, like that. So the way I'm going to name them would be what? Give me one name. Give me the red. Nope, blue. It was blue. How would you name the blue ray? RT. Okay, so you do RT with a ray pointing to the right. And how would you name the green one? RS. So ray RT and ray RS are opposite rays. Okay, we can't overlap at all. So you can't say ST and RS because then that whole RS overlaps, right? So no overlap, they only share an endpoint. Any questions on that? Okay, last thing is just a second example here. Let's say we have point D, point E, and point F. Okay? Tell me any segments you see here. Can you give me a segment? Don't be bashful. And I want a lot of different people giving me answers here. Hold on. Yanni, but I can't remember your first name because I want to call you your brother's name. Hold on. Andrew.
Yes.
Andrew. Got it. Okay.
Segment
DE. Segment DE. What's another way to name that same segment? ED. Okay. So we don't need ED because we have DE. Okay. Angelina. Segment DF is another segment. Another way to name that would be FD, right? So we don't need to use that one. What's the last one? Last segment. Yeah. EF. Okay, so those are our segments in the picture. Can you name some rays in this picture? Yeah.
E.
Connor, right?
Yeah.
ED. So ray ED, right? That would be this one, from E this way, right? That's ray ED. Devin. Ray EF is starting at E and going through F. Okay, so ray EF. Any other ones? What if F is my end point? What would it be? Bryce. Okay, question. Ray FE, right, starts at F and goes this way. What about ray FD? It's the same ray, right? Because the line keeps going. So you don't have to give me FE and FD because it's the exact same endpoint going through all the same points, okay? So what about D? I'm out of colors. If we start at D, you could name it what? DE or DF, and it's the same ray. So DE or DF with the ray over top, okay? How about a pair of opposite rays? I'll give you a hint. There's only one. Chris.
Ray, ED, and EF.
Right, ray ED. Remember, you have to start at the end point, so E first, and ray EF. Okay? Tell me this. Are EF, no, just kidding. That was just an add-on. You don't need it. Have a lovely day.